Breaking news from deep space. At 0347 a.m. UTC, an automated alert flashed across the monitoring systems of multiple observatories around the world. Within seconds, identical signals began appearing in data streams from NASA's Deep Space Network, the European Space Agency telemetry arrays, and several independent sky survey instruments tracking an unusual interstellar visitor known as 3I Atlas. For weeks, astronomers believed this object was simply another rare traveler from outside our solar system. But moments ago, the data changed. Spectral readings shifted, energy output spiked, and something appeared in the signal, something no one expected. Today, the impossible just happened because buried inside those transmissions was a pattern so precise, so mathematically structured that some scientists are now quietly asking a question that until now belonged only to science fiction. Did we just find evidence of alien life and no one told us? If you want more updates on cosmic mysteries like this one, make sure to like this video and subscribe, because what scientists are discovering right now about 3I Atlas could change everything we thought we knew about our place in the universe. The story begins with a discovery that already seemed extraordinary. 3I Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System, a network of survey telescopes scanning the sky for potentially hazardous objects. Unlike ordinary comets or asteroids born inside our solar system, this one was moving too fast, much too fast. Initial measurements placed its velocity at 72 kilometers per second relative to the Sun, well above the escape velocity of any solar system-bound object. That meant one thing. It came from somewhere else, an interstellar traveler. Within hours of confirmation, observatories across the planet turned their instruments toward it, from the National Aeronautics and Space Administration tracking facilities in California and Australia to the European Southern Observatory telescopes in Chile's Atacama Desert to radio dishes scattered across Europe and Asia. Scientists began recording every possible detail. Then the world's most powerful space telescopes joined in. The James Webb Space Telescope locked onto the object using its infrared instruments. Soon after, the aging but still remarkable Hubble Space Telescope added ultraviolet observations. Data poured in from multiple continents, multiple wavelengths, and multiple instruments. And at first, everything looked normal. 3I Atlas appeared to be a small, icy body, roughly 1.8 kilometers across, surrounded by a faint cloud of gas and dust, the typical coma of an active comet warming under the sun. But then the timeline of anomalies began. 48 hours before the event, analysts studying the motion of 3I Atlas noticed something subtle. Its trajectory was shifting. Not dramatically, not violently, but just enough that gravitational models stopped matching the observations. Normally, comets accelerate slightly as sunlight heats their surfaces, releasing jets of gas that act like tiny thrusters. But the thrust measured for 3I Atlas was different. Instead of chaotic bursts of outgassing, the force appeared smooth, controlled, and directional. A sustained thrust equivalent to 0.003 meters per second squared. Small, but far too precise. Dr. Elena Markovich, an orbital dynamics specialist working with the European Space Agency, later described the moment her team realized something was wrong. The thrust vector always pointed along the same axis. Always. No natural comet behaves that way. 11 hours later, a second anomaly appeared. Spectroscopy data from the Atacama Large Millimeter Array detected unusual emission lines in the object's surrounding gas cloud. Instead of the typical signatures of water, carbon monoxide, and methane expected from a comet, researchers observed a faint but persistent line at 1.42 gigahertz. That number immediately raised eyebrows. Because 1.42 gigahertz corresponds to the hydrogen line, a frequency long considered a universal reference for interstellar communication. At first, scientists assumed it was background noise, cosmic radiation, instrumentation interference, but the signal did not fade.
Instead, it repeated, every 17.2 seconds, exactly. As the hours passed, the mystery deepened. The James Webb Space Telescope recorded temperature readings on the surface of 3I Atlas that defied expectations. Portions of the object were warming to 430 Kelvin, far hotter than sunlight alone could explain at its current distance of 1.6 astronomical units from the Sun. Meanwhile, other regions remained extremely cold.
Barely 110 Kelvin. The result was a thermal pattern unlike anything ever seen on a natural comet. Almost geometric, almost engineered. 27 hours before perihelion, the moment when the object would pass closest to the Sun, another discovery stunned researchers. High-resolution imaging revealed that the shape of 3I Atlas was changing, not through explosive fragmentation or chaotic breakups, but through slow structural shifts. Panels, or what looked like panels, were rotating relative to the main body. Tiny but measurable. Dr. Nathaniel Ortiz of California Institute of Technology described the structure as resembling interlocking segments. That observation triggered the first serious internal debate among scientists. The mainstream explanation argued that 3I Atlas might simply be a highly fractured comet nucleus. As volatile ice sublimated under solar heat, internal stresses could cause slabs of material to shift or collapse. A rare process, but still natural. Yet a second group of researchers proposed something far more controversial. What if the object wasn't just a comet? What if the observed thrust, heat distribution, and repeating radio pulses were signs of technological activity? At first, that idea remained confined to private discussions, emails, late-night conference calls, unofficial working papers. No one wanted to make extraordinary claims without extraordinary evidence. Then came the event that changed everything. At 03:47 a.m. UTC, exactly 14 hours before perihelion, the signal pattern changed. Until that moment, the signals detected near the hydrogen line had been identical, a simple repeating beacon every 17.2 seconds. But suddenly the intervals shifted. 17 seconds, then 19, then 23, then 29. The pattern was unmistakable. Prime numbers. A sequence known throughout mathematics as one of the simplest indicators of intelligent design. Inside control rooms around the world, scientists watched the signal cascade across their monitors. 17, 19, 23, 29, 31, 37. No natural astrophysical process produces prime number timing sequences. None. Within minutes, internal alerts spread across multiple agencies. At NASA, analysts initiated priority observation protocols normally reserved for potentially hazardous near-Earth objects. The European Space Agency activated secure communications between their deep space tracking facilities. And researchers at several universities began running massive simulations, feeding the incoming data into computational models. One hypothesis suggested that the signal might be the result of complex magnetospheric interactions between the comet's ionized gas cloud and the solar wind. But every simulation failed. The timing precision was simply too perfect. Then came the second wave of anomalies. 7 hours later, as 3I Atlas approached within 0.9 astronomical units of the Sun, one of the object's outer fragments separated from the main body. At least, that's what the optical telescopes reported. But radio instruments saw something else. Instead of drifting away randomly like a typical comet fragment, the detached mass moved along a precise arc, a controlled trajectory. Within 20 minutes, it disappeared completely. Not destroyed, not vaporized, it simply faded from all detectable wavelengths. Visible, infrared, radio. Gone, as if something had powered down. At this point, scientists realized they were no longer dealing with a simple cometary breakup. Dr. Adrian Shaw, a computational astrophysicist at Harvard University, summarized the growing concern in a confidential briefing. Either we are observing the most complex natural phenomenon ever recorded, or we are witnessing technology operating on an interstellar scale. The room reportedly fell silent. Back on Earth, subtle consequences began to emerge. Shortwave radio operators across several continents reported unexplained bursts of interference at frequencies near the hydrogen line. Several satellites experienced momentary navigation errors lasting less than 3 seconds, and magnetometers in northern Canada detected a brief disturbance of 12 nanoteslas, a fluctuation small but unusual given the calm conditions of Earth's magnetic field that night. Individually, none of these effects proved anything, but together they suggested a connection. Meanwhile, the prime number pulses continued. 17, 19, 23, 29, 31, over and over, as if something out there was deliberately announcing its presence or testing whether anyone was listening. Inside observatories and research institutes around the world, the atmosphere shifted from curiosity to cautious alarm. Because if 3I Atlas truly contained artificial technology, the implications were staggering. Interstellar travel, autonomous probes, civilizations capable of sending machines across light years of space. For centuries, humanity has looked up at the night sky and wondered whether we are alone. Perhaps the universe has been answering that question all along. Perhaps we simply didn't recognize the message. Because somewhere beyond our solar system, something launched an object that has now crossed unimaginable distances to reach our sun. And for a brief moment it spoke. Then it fell silent again. But here's the final detail that keeps many astronomers awake at night. The trajectory of 3I Atlas after its solar encounter has changed slightly, very slightly. Enough that new calculations suggest it will pass closer to Earth's orbital path on its outbound journey than originally predicted. Still millions of kilometers away, perfectly safe, yet close enough for our instruments to observe it again. Which means the opportunity and the mystery is not over. Because if those signals return, if the prime number pulses begin again, then humanity may be facing the most important discovery in the history of science. And the next time 3I Atlas speaks, we may finally understand what it's trying to say. Until then, keep watching the skies. And if you want to follow every new update as scientists continue unraveling this cosmic mystery, make sure to subscribe. Because the story of 3I Atlas is still unfolding, and the next signal could arrive at any moment.